So, get this. You have a total legend in computer science. I mean, a real giant in the field, and he's been wrestling with this super tough math problem for weeks. Then, out of nowhere, he finds out an AI just solved it. This isn't some sci-fi movie plot. It's a true story about a breakthrough that might just be changing, well, everything. Let's get into it.
And hey, don't take my word for it. These words right here, they're from Don Knuth. If you know anything about computer science, you know that name. He literally wrote the book on it, The Art of Computer Programming. So when a mind like that says he's in shock, you know something absolutely huge has just gone down.
All right, so let's unpack this shocking discovery. We're going to treat this whole thing like a detective story, right? The case of the unsolvable math problem. And our victim is this really tricky problem in a field called graph theory. But the lead detective, well, that's where the story gets really, really interesting. What blows my mind is just how fast this all happened. So you've got Knuth, this human genius, pouring weeks into this thing, and in the background, a brand new AI model gets released to the public, and almost right away, Knuth's collaborator, a guy named Philip Stappers, basically decides to, just ask the AI. And the result wasn't just some quick answer, it was a genuine breakthrough.
Okay, so to really get how big a deal the solution is, we gotta understand the problem first. And it's actually a pretty cool one. It's kind of like trying to plan the perfect tour of a very weird, very specific city. Let's take a look at what made this challenge seem so impossible.
So the key idea here is something called a Hamiltonian cycle. The easiest way to think about it is as a perfect city tour. Imagine you have a city with a bunch of intersections connected by a whole network of one-way streets. A perfect tour means finding a single path that hits every single intersection exactly one time and then brings you right back to where you started. No backtracking, no missed spots, perfect.
But the problem Knuth was working on? Way harder. He wasn't just looking for one perfect tour. He wanted to know if you could take all the one-way streets in this mathematical city and split them up into 3 totally separate perfect tours. So tour A has to be perfect, using only its set of streets. Then tour B has to be perfect, using a different set of streets. And finally, tour C has to be perfect, using whatever streets are left. 3 perfect tours, all at once, using every single connection. That is a ridiculously hard challenge.
So faced with this massive challenge, Philip Stappers turns to this new AI, Claude. And what happened next wasn't some magical flash of insight. No, it was more like an investigation. So let's actually look through the AI's logbook and see how our digital detective started to piece together the clues.
This really shows you how the AI actually thought about it. It didn't just spit out the answer. It started off just like a person would, trying the simple stuff. Brute force attacks. That was way too slow. Then it found this promising idea it called a serpentine pattern, which was pretty smart, but turned out to be a dead end. For a while there, it just hit a wall. Tried a bunch of things that went nowhere. The whole investigation could have died right there. But then, on its 15th try, it found a new clue. A totally fresh way of looking at the problem it named fiber decomposition.
But let's be super clear here. This was not some kind of magic trick. The AI wasn't just locked in a digital room by itself. It needed a human partner. Stappers was right there with it, kind of guiding it, restarting it when it crashed, and constantly telling it, hey, write down what you're doing. This was a collaboration, a real back and forth between an expert and his very powerful new tool.
And that incredible collaboration led to this, the aha moment. That beautiful point where a super messy, complicated problem suddenly just clicks into place. Let's see how they got to the solution.
So think about it. How would you even start to simplify a crazy, complex 3D problem like this? I mean, with so many parts all interacting, where do you even begin?
The AI's answer was fiber decomposition, and this is just a brilliant insight. It basically realized it could reimagine the whole 3D puzzle as just a stack of 2D layers. Seriously, imagine slicing a sugar cube into a bunch of paper-thin sheets. Instead of trying to solve the whole cube at once, you can just analyze how the paths move from one slice to the next. It was this genius way of reframing it that made the impossible challenge possible.
And here is another just jaw-dropping moment. After trying this other technique to just find one-off answers, the AI basically said to itself, okay, this isn't going to work. Finding one solution at a time is not good enough. I need a general rule. I need pure math. It literally recognized the limitations of its own strategy and pivoted to something way more abstract and powerful. I mean, that's not just number crunching. That's something that looks a whole lot like reasoning.
And that shift to pure math is what led directly to this, the solution, a really elegant, general rule that cracked the case. Well, at least for a specific group of numbers anyway. So what did this big, fancy solution actually look like? Was it some 100-page mathematical proof? Nope. The AI's final report was a piece of code. And that's the real beauty of it. The code is the proof. It's like a little machine, a set of instructions that can build you the 3 perfect tours for any valid city size. It's not just an answer, it's the recipe to make all the answers.
So how's the code work? Well, without getting totally lost in the details, it just sets up a few simple rules. Based on where an intersection is, it decides which of the 3 paths to follow. It's this incredibly clean system. Like, if the coordinates add up to 0, you follow one rule. If they add up to the max value, you follow another. And if it's anything in between, you follow a third rule. Simple little conditions that create these unbelievably complex and perfect paths.
And now for the final plot twist. You'd think finding even one general solution would be the discovery of a lifetime, right? But the thing is, the AI didn't just find one. It turns out the solution Claude found is just one member of a whole family of similar solutions. There are 760 different Claude-like ways to solve this problem. The AI didn't just trip over an answer. It uncovered a deep, fundamental structure in the math itself.
But, just like in any good detective story, when you solve one mystery, it often just points you to the next one. The case isn't fully closed. There's a brand new puzzle to solve.
So here's the catch. Claude's beautiful, elegant solution, it works perfectly for problem sizes that are odd numbers, 3, 5, 7, and so on. But what about the even numbers? Well, for those, the problem is still a complete mystery. The case is very much still open.
And get this, the sequel is already happening. When stoppers put Claude on the even number problem, it just got stuck. But literally just days later, another researcher shared that a different AI might have generated a solution for the even numbers. The only problem? This new solution is being described as far more chaotic, which basically means it's going to be way, way harder to prove that it actually works all the time. The race is on.
And that brings us right back to Don Knuth. His first reaction was shock, but that quickly turned into pure joy. He wasn't just happy that his little problem got solved, he was celebrating a dramatic advance in how we solve problems, period. He saw this not as a machine taking over, but as a whole new chapter in the awesome story of discovery.
And that kind of leaves us with this final thought to chew on. We just watched an AI go through a process that looks an awful lot like intuition, creativity, and abstract thinking to solve a problem that stumped one of the greatest human minds in the world. So the question isn't just about math anymore, is it? It's about, well, everything. What problem is it going to solve next?